everybody. Today we are going to this particular example for preliminary hydraulic calculation for fuel gas scrubber return pump to check whether pump can push fluid to the destination or not. The objective is to make preliminary calculation on the suction and discharge line, hydraulic calculation and pump sizing. We try to break down the problem to see what are the design, input, and assumptions. In this problem, you are given the viscosity, specific gravity, or density of fluid, and also the flow rate of liquid. But this flow rate is normal flow rate. First, we find flow rate or capacity for design or rated flow rate, which is 1.1 or 10% over the normal flow rate, almost a good factor to calculate design flow. So 855 is 1.1 multiplied by 777. Next step is to calculate suction pressure. Why we want to calculate suction pressure? Because the terms that are important for us today to calculate, one of them is differential pressure. And differential pressure is nothing but the discharge pressure, the difference between discharge pressure and suction pressure. And also another factor we want to calculate is shutoff pressure. Another important factor is NPSH and power also. So to calculate suction pressure, first we want to know how to calculate it. There are given values such as normal vessel pressure and static head. So if we come here and we assume that this is our tank, and the inlet of the or in the suction line of the pump, we know that this tank by itself has a normal pressure. So we have a normal pressure, and then we know that also this tank has a level based on the destination or elevation that this tank has based on the grade, and we can figure it out the static head, but usually for vessel on the suction of the pump, we use the low liquid level to calculate static head. So we know that also to calculate the suction pressure, so in order to calculate the suction pressure, we know that we have to add normal pressure of the tank plus static head minus losses. Okay, these losses in the line is strainer loss and line losses. In order to calculate the line losses fast, we made another tab in a spreadsheet to calculate this loss on the suction line for us easy. So we are looking at the line which started from the vessel and then it goes to pump. We know that so pipe size, pipe flow rate density, viscosity, and pipe schedule are given data, also the pipe length. So based on these values, based on the schedule of the pipe and size of pipe, we can find the inlet inside diameter based on the tables in crane book. And regarding to pipe thickness, we can find the area, and also we can find the velocity of the flow through the suction line. And velocity is, we know that the velocity is equal to volumetric flow rate divided by area, and this area is equal to pi inside diameter power 2 divided by 4. Then after we figured out what is the flow rate, we can calculate the Reynolds number. Okay, how we can calculate the Reynolds number? Formula for Reynolds number is Reynolds. Okay, so we have to shift this. Reynolds number equal to density multiplied by velocity multiplied by inlet diameter, which we show in ID, and divided by viscosity. So we figured out what is the Reynolds number. Based on Reynolds number value, we can find if the flow is laminar or turbulent. So since Reynolds number is lower than 2000, it's laminar. Then based on the absolute roughness can be calculated based on the pipe material. And then we can figure it out what is the relative roughness, and then we can figure it out what is the friction factor from the Moody diagram. So relative, we can based on Reynolds number, and based on the Reynolds number and based on the relative roughness, which is epsilon divided by d for inside diameter, then we can go to Moody diagram and find the friction factor, which is here 0.1. We have the length of the line. We can also calculate the fitting equivalent length. I mean the how much the fitting has pressure loss on the line, but equivalent to the length of the pipe, and the total pressure loss is 0.02. We can use this value in our pump calculation. Here you can see that we use that in line loss for suction line. So then based on this formula we can find the suction pressure. Okay, so we want to calculate net positive suction head. What is net positive suction head? So we know that another important factor pump is net positive suction head, and is nothing but suction pressure minus vapor pressure. Vapor pressure of the liquid is given to us, and we already calculated the suction pressure. So net positive suction head is this value, and we can change it to head or based on feet or based on meter. Discharge pressure is another factor that we are looking to find the value for that. So in the difference between suction pressure and discharge pressure is that for suction pressure, we subtract the losses, but for discharge pressure, based on whatever we have in the discharge of the line, it can be another tank or it can be a transfer line. For us is a transfer line, and we know the pressure, the destination pressure that we have. So we use that destination pressure plus the static head, which is based on the elevation of that destination point. So we have the static head, but here we add losses for the suction line. Previously we used the minus, now we use the plus. And okay, on the discharge line we might have control valves or other equipment or fittings. We add all of them and then we find the discharge pressure that we have. Now discharge pressure is almost 400 psi. Then we can figure it out what is the delta P. I mean the pressure, pump pressure loss or pump delta P, which is nothing but discharge pressure minus suction pressure. So if we subtract these two values, we can find the delta P and then we can find the head based on that. Another important factor for us is shutoff pressure. Okay, so for shutoff pressure, we know that shutoff pressure is equal to maximum suction pressure plus 120% over the delta P of pump. So why I say maximum? This suction pressure is different from the suction pressure that we calculated usually because this is maximum suction pressure. So it means that in our tank, if we want to calculate the maximum suction pressure, there is another level here which is high liquid level. And this maximum suction pressure is calculated based on that high liquid level, not low liquid level. And the value that we have for that is, here we can see that, is 230 plus 1.2 of the delta P, and then the net value is 645 almost psi. The last but not the least is to calculate the power. In order to calculate power, first we calculate the hydraulic horsepower. Hydraulic horsepower is equal to flow rate, which is a gallon per minute, divided by 1715. This is to change the units, and multiply by NPSH, which we have 0.4 here as the horsepower. Then another formula that we have here is brake horsepower. Brake horsepower is nothing but 100 multiplied by hydraulic horsepower divided by pump efficiency. But we have to talk about two types of efficiency. One of them is the pump efficiency that we have. Another efficiency that we have is based on motor efficiency. These two efficiencies are not the same. So for power calculation, we use the motor efficiency. So for power calculation, here we use the operating power is 0.746 multiplied by 100 multiplied by brake horsepower divided by now motor efficiency. So for power, we use both motor efficiency and pump efficiency. So now is the end of this calculation. We already calculated all the important factors for calculating pump and pump sizing. Thank you for your attention.